The second recipient of the Engineering Medal for Research and Development is Dr. Kibret Mequanint.
My name is Kibret Mequanint, and I am a professor in the Department of Chemical and Biochemical Engineering at Western University. After I completed my PhD, I took postdoctoral fellowships, and I spent about 3 years doing advanced research in the areas of macromolecular engineering, biomedical engineering, and chemical engineering. Through these advanced studies, I was introduced to a large extent to the research area that I am currently doing. I am very passionate in teaching as much as I'm passionate about doing research. What I really found most interesting about the field that I do is we are really trying to invent the future of medicine, the future of medical technologies. And I get a lot of motivations, when I sometimes read stories about, patients undergoing certain interventions and then the intervention doesn't work. So all these things could be addressed in the field of research that I'm currently doing, and that is tissue engineering, regenerative medicine, and translational research. The translational piece is important because we want to take our technology from a lab to the patient. So it's exciting because our population is aging, and so there are a lot of medical technologies that are required. And so being part of that group of scientists doing this type of research is very exciting to me. I was fortunate over the years to be involved with a number of projects, some of them commercialized, some of them are in the pre-commercialization stage. One of the earliest technology is the work that we have done in developing a gel dosimeter that can determine the amount of radiation that is deposited into patients when they are undergoing radiotherapy procedures. There are 3 treatment approaches for cancer: surgery, radiation, and chemo. No single intervention is sufficient, so at least 2 of them must be combined. In a situation where radiotherapy is required, the radiation oncologist prescribes the amount of dose that the patient needs to receive in order to shrink and kill the tumor. Although the radiation delivery instrument can deliver the exact amount that is programmed, what is unknown is how much of that delivered dose actually gets to the site where it's needed. And so what we have developed is a way to predict the actual dose distribution. So what the gel that we have developed here in my lab does is the following. We take tumor simulating jello material that has got radiation sensors embedded in it. And so when the gel is exposed to the radiation delivery unit, depending on how much radiation is delivered, the gel changes color. That color change is proportional to the amount of dose that is delivered to the tumor. It's easy to design a radiation-sensitive molecule that can respond to high doses, but it is extremely difficult to design a radiation sensor that can respond to 5 gray or 2 grays of energy that's delivered to patients. I'm originally from Ethiopia. There are a number of initiatives that I do in East Africa. Around 10 years ago, I was asked to assist a number of universities in Ethiopia in their capacity building and curriculum development. And we were able to design a graduate program for 3 universities in Ethiopia. I also helped them to develop and design cheaper medical devices. I can go on and on about it, but I'm extremely passionate about it because I think at the end of the day, they don't have the technology that we have, but we have the responsibility to help them as well.
As an internationally renowned innovator and scholar at the nexus of chemical and biomaterials engineering, life sciences, and transitional medicine, Dr. Kibret Mequanint is being honored with the Engineering Medal in the Research and Development category.